So now we're going to move on to example 3. So if we have a look at the notes, you can see here, example 3 on page 59, and it's the integral of 2x bracket x squared plus 3 to the power of 4 dx. So let's work through this one. So the first thing you'll notice is that there is nothing in the table of standard integrals that looks even close to this. So what we're going to do is we're going to take this bit here, the x squared plus 3, and make that our u, x squared plus 3. Okay, so this becomes the integral of 2x times u to the power 4th dx. But of course, we've got a u here, and we've got an x here, but we can ignore that at the moment. We've got a u here, and we need to change this to a du here. So we go back here and we find the derivative of this. So du by dx is equal to 2x. So we're after the dx here, so that goes up there, and we get du equals 2x times dx, and then the 2x comes back down, changes from a times to a divide. So we get dx equals du over 2x. So now I can go back here and I can put it in here, 2x times u to the power 4th times du over 2x. And very fortunately, these cancel. So that leaves us the integral of u to the power 4th du. Now we can do that fairly straightforwardly. That's raise the power by 1, divide by the new power and add a constant. And that's us done, except we need to replace the u with our substitution, x squared plus 3 up here. So that's going to go all the way back down. So that becomes x squared plus 3 to the power of 5 over 5 plus a constant. And that's it done. You could also write this as a fifth of x squared plus 3 to the power of 5 plus a constant. So let's go back up and review what we did. Start with the problem, put the difficult looking bracket part, call it u, and then use that by differentiating it to find out what dx would be. And then that goes back into the integral to replace the dx there. It cancels off, the 2x's cancel off. And that leaves us a simpler problem in terms of u, which can then be integrated, and then we put the substitution back in. And that's it done. Now, just a quick point. The key thing to this was when we get to here, there are no x terms in here at all. Okay, so at this line here, we've just got u. And that's an important thing to want to achieve. And fortunately, the 2x that came out of the dx equals du over 2x cancels with the 2x on the top line. So that they cancel out, and that is extremely important here. So what we can say is we can see that the derivative of this thing in the brackets is this thing here. And if that happens, if the derivative of the bit you're going to substitute for u is equal to or a linear multiple, or an integer multiple of the rest of that term, then you're liable to get some kind of cancellation, and that's what we're looking for. That's a key feature of this type of problem. So in the next video, we'll look at the next example.